Welcome back to Matt's Playground. Today we'll be taking 5 random questions and solving them. Our first question is, the sum of 25 consecutive even integers is 10,000. What is the largest of these 25 consecutive integers? Okay, so this should be easy. We, we divide, we're going to divide, 10,000 by 25, so we can find the middle term, which is 400. So let me write down all of the terms. So term 1, term 2, term 3, term 4, term 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, almost there, 22, 23, 24, and 25. Sorry, 25. There we go. So, so obviously 13 is the middle term. We found that this is 400. So now let's see how many terms there are. We need to find the largest, so let's see how many terms there are in front of this. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And since we're going with even integers, we're going to add, add, um, we're going to do 400 plus, here's the catch, we're going to do 12 times 2, because each of these, and between each of the terms, there's an interval of 2. And since we don't want to get rid of that, we have to multiply by 2, which gives us 424 as our greatest term. Okay, that wasn't too hard. Second question. Annie and Bonnie are running laps around a 400-meter oval track. They started together, but Annie has pulled ahead because she runs 25% faster than Bonnie. How many laps will Annie have run when she first passes Bonnie? So, let's just figure out what this question means. So, if this is the oval track, it looks more like a circle, and this is the starting line. So it asks when Annie first passes Bonnie, when Bonnie is here, Annie comes around and passes Bonnie from here, from the starting line. So by the time Bonnie has run 1 lap, by the time Bonnie has run 1 lap, um, Annie has run one 1.25 laps, which is equal to 5 quarters of a lap. So now we have to find a number which which we can multiply 1 and 5 by 4 by, so that both of these end up as a whole number. So whatever you multiply it with, it's going to be a whole number unless you multiply it with a fraction, which probably wouldn't be the best idea since we already have a fraction, 5 by 4. So since the denominator is 4, we're going to multiply by 4. So by the time Bonnie has so by the time Bonnie has run 4 laps, Annie has run 5. So that's your answer. 5. Okay. Question 3. What is the largest power of 2 that is a divisor of 13 to the power 4 minus 12 to the power 4? So, this should be easy because we know that a squared minus b because uh, a because a squared minus b squared is equal to um a plus b times a minus b. So let's use this. So over here we would get 13 squared minus 11 squared times 13 squared plus 11 squared. So so we have 13 squared minus 11 squared, which we can also write as 13 plus 11 times 13 minus 11, right? And now this would become 169 plus 121, which is 290. So this whole part would become 48 times 290. Okay, so we can write this as 290 times 2 times 24. Okay, so we can write 290 as 2 times 145 times 2 because of this one times we can write 24 as 2 times 2 times 2 times 3. Look at how many cubes we have here. We have 1, 2, 3, 4, 5 cubes. So our answer would be 2 to the power of 5, which is equal to 32. And 32 is the largest power of 2 that is a divisor of 13 to the power 4 minus 11 to the power 4. Okay, so now it's our first question. A semicircle is inscribed in an isosceles triangle with base 16 and height 15, so that the diameter of the semicircle is contained in the base of the triangle as shown. What is the radius of the semicircle? Okay, so we can start by making the height, which the question tells us is 15, and we can call this point O. So that OC is the height, and we know that OB is 8. Okay, now let's draw a radius right here. Okay, so now we can use the Pythagorean theorem to figure out what the length of CB is, or BC. So 15 squared, we get 15 squared plus 8 squared is equal to 225 plus 64, which is equal to 289, which is equal to 17 squared. So we know that BC is 17. Okay. So the area of the triangle, so the area of triangle BOC is equal to half of 8 times 15, which is equal to 60. Okay, so since we're trying to find out oh, let's call this point E. Since we're trying to find out OE, we we know that since BC is tangent to the semicircle, we know that angle OEC is 90 degrees. So we also know that OE can also be a height of BOC when BC is the base. So another way to write the height would be half of OE times 17 is equal to 60, which we found out the area was of BOC. So then OE times 17 is equal to 120. So OE is equal to 120 divided by 17. That was pretty easy. Okay, our last question. In triangle ABC, point D divides side AC so that AD is to DC is equal to 1 is to 2. Let E be the midpoint of BD, and let F be the point of intersection of line BC and line AE. Given that the area of triangle ABC is 360, what is the area of triangle EBF? Okay, let's start out by finding some areas that we already know. So, since 80 is to DC, is 1 is to 2, AC is to DC would be 2 is to 3. AC is to DC would be 3 is to 2. And the base of ABC, of triangle ABC and triangle BDC is the same, BC. And we know that the height of triangle BDC must be 2/3 of the height of ABC, since AC is to DC is 3 is to 2. So we know that the area of triangle BDC, or BCD, whatever, is equal to 240. So then if we subtract 240 from 360, we'll find the area of triangle ABD. So if we do that, then triangle ABD's area would be 120. Okay. Now if we can find ABE, so since ABE has the same height, which is from here to here, as ABD, we know that that the height is same. So we also know that E is the midpoint of BD, and if we take BD as the base of ABD, then the base of ABE would be half of the base of ABD. So we know that ABE is half the area of ABD, which gives us that ABE, the area of ABE must be 60. Okay, so now let's just find the ratio of the height of EBF to the ratio of the height of ABC. So since we know that the ratio of the height of BDC and the height of ABC is 2:3. We can just find the ratio of the height of EBF and the height of BDC. So we know that BE is half of BD. So since BE is the side of EBF and BD is the side of BDC, and BE is half of BD, we know that the height of EBF must also be half of the height of BDC. So then the ratio of the height of EBF to, to the height of ABC must be 1:3, which we can also write as 1/3. So since we know that the area of A that the base of ABC, which is BC, is not the same as the base of EBF, which is BF. We're going to do this instead with ABF, which also has the same height as ABC. This one, the one I drew and did. So, we know that the area of triangle ABE is 60. So, and if we take if we call the area of EBF X, then we would get X divided by X plus 60, which is the area of ABF, is equal to 1/3, the ratio of the heights, which must also be the ratio um of the area, since the base of ABF and EBF is BF, which is the same. So let's cross multiply. We get 3x is equal to x plus 60, which gives us that 2x must be 60, which means x is equal to 30. So the area of EBF, so the area of EBF is equal to 30. We did it! See you next time.